welcome in channel of Mr. Statistician. Today we are solving GATE 2019 question number 7 of statistics paper. Let's get started. Let x1, x2, xn be the random sample from uniform distribution defined over 0, theta, where theta is greater than 0 and n is greater than equal to 2. Let x of order 1 equal to minimum of x1, x2, xn and x of order n equal to maximum of x1, x2, xn. Then covariance between x of order n and x of order 1 divided by x of order n is given that x1, x2, xn follows IID uniform 0, 1 because x1, x2, xn is a random sample from uniform 0, theta. We always remember this result. We use this result in many problems. If x1, x2, xn be random sample from uniform 0, theta, then x of order r upon theta follows beta distribution of first kind with parameter r, n minus r plus 1. Let r equal to 1. Therefore, x of order 1 upon theta follows beta distribution of first kind with parameter 1, n. Here in the problem, n is also n minus r is 1 plus 1 is equal to beta distribution of first kind with 1, n. This because x1, x2, xn is a random sample and x of order n upon theta follows beta distribution of first kind. Here r equal to n, so beta distribution of first kind r is n, n minus r is also n plus 1. It is equal to beta distribution of first kind n, 1. That is x of order 1 upon theta follows beta distribution of first kind with parameter 1, n and x of order n, theta follows beta distribution of first kind with parameter n, 1. We take ratio of these two random variables, that is ratio of these two order statistics. X of order 1 upon theta divided by x of order n upon theta is similar to beta distribution of first kind with 1, n upon beta distribution of first kind with n, 1. This is x of order 1 upon x of order n is similar to beta distribution of first kind with parameter 1, n. Beta distribution of first kind with parameter n, 1. This is a ratio of beta distribution of first kind with parameter 1, n and beta distribution of second kind with first kind with parameter n, 1. This is a two random variable, and this here observe that beta distribution of first kind does not contain unknown parameter theta, and also this beta distribution does not contain parameter theta, that is it is free from theta. Therefore, x of order 1 upon x of order n has distribution is free from theta, This is equation star. We know that statistics t, x of t is said to be ancillary for theta if distribution of order statistic t, distribution of t, not order statistic, distribution of t is free from theta, that is does not depend on theta. T is said to be ancillary about unknown parameter theta if distribution of T is free from theta. Here we observe that by star x of order 1 upon x of order n distribution is also does not depend on theta, it is free from theta. Therefore, x of order 1 upon x of order n are ancillary for theta, are ancillary about unknown parameter theta. So we prove that x of order 1 upon x of order n is ancillary for theta. We need to prove that here in this problem we use De-Vasu theorem to solve this problem. In this theorem, first condition is to show that statistic T is ancillary for theta and any other statistic T is a consistent and sufficient statistic for theta, then T and U are independent. This other statistic and T statistic we assume these are independent. So first we proved that x of order 1 upon x of order n is ancillary statistic for theta. Also we know that x of order n is sufficient and consistent for theta. So here we use De-Vasu theorem. You tell that De-Vasu theorem's statement, if T is complete and sufficient statistic for theta and phi is ancillary statistic for theta, then T and phi are independently distributed. Here T is x of order n is complete and sufficient for theta and phi is equal to x of order 1 upon x of order n is ancillary for theta. This implies that T and phi, that is x of order n and x of order 1 comma x of order n, are independent. We know if x and y are two random variables are said to be independent, then if x and y be two random variables are independent, then covariance between x comma y is equal to 0. This is also important result. We always remember this result implies that here T and V are independent, that is x of order n comma that is x of order n and x of order 1 upon x of order n are independent. This implies that covariance between x of order n comma x of order 1 upon x of order n is equal to 0. That's why first answer is true.